Hello, good morning to everybody. First of all, I want to introduce myself. My name is Kai Justinius. I am from Dines Technologies company in Germany. I'm the general manager, and I'm happy to be here now to talk a little about UVC and ozone and what kind of possibilities you have with this kind of, let's say, disinfection solution, and where it's possible to apply in hospitals. Dines Technologies company, we are located in southwest of Germany. We are founded in 1979, so we are quite a long time already on the market. And we have now our main focus is in the healthcare sector and also in the food industry. Okay, then let's start. So what is the motivation actually for the UVC or ozone disinfection? I think everybody has still it in mind. We have not long time ago a big pandemic, so with our COVID, and there was a big confusion everywhere in the world. So what to do, how to do, what kind of methods are working, and what kind of strategy we can go, etc. And that was a big, also I think a bit big possibilities for UV, where you could apply it very effectively. Another motivation is, we had heard before already in the presentations, these hospital germs. Here I put some figures on it from Germany, from the Robert Koch Institute. So we have alone in Germany about 600,000 infections per year. We have about 20,000 people die from these infections, and the costs, roughly, we can say per infected patient, it's about 25,000 euro, roughly. If you calculate this one in average on the hospital, so that means every hospital actually suffers cost about 7.6 million just from these infections. So it's quite a big figure with this problem. So what can we do about the UVC? UVC actually is nothing new. It's a quite old technology. Actually, it was first in the end of the 18th century with some pioneers. They found out that it was Downs and Blunt. They found out that the sunlight have a very good, strong disinfection. Yeah. So and they started a lot of things a long time ago, and they also started to develop then the first UVC lamps, and then later that was this Mr. Kaiser, a physician, and he found out that he started with the blue light to treat also even some patients. So it's nothing new, and it's already a long-term history. And but let's say the technology about the lamps itself, that was quite developed in the last years. So when we are talking about UV, we have actually, you can see here the total spectrum. When we talk about UV, we start with 380. We divide UV actually in three sections. It's UVC, UVB, and UVA. What you have in the sunlight is normally UVA and UVB, and the UVC actually is blocked by the atmosphere around the world. Yeah. So and we're working with 254 or 185 nanometer. So what is the difference of that one? 254, we call it normal UV light, and in the normal UV light actually you can do the disinfection through DNA modification, and the 185 nanometer, that's already ionizing wavelengths, and it starts to create ozone out of the oxygen in the air. So it's a big difference, and it's also a different kind of let's say functionality of the disinfection. So this one I just mentioned already. If we are using the 254 nanometer, the effect will be that we're changing the DNA of the organism so that they cannot reproduce anymore. And if an organism cannot reproduce, he will die. A very simple and very effective method. What is the, let's say, the efficient, or on which kind of points depends this efficiency? Yeah. So we have first of all is the microorganism itself. So that means it depends what kind of microorganism do you have. So if you have a virus, or if you have bacteria, if you have mold, so in general, you can say as bigger the organism, as more difficult to kill it. Yeah, so if you have a small one, it's easy to kill. A big one is difficult to kill. Then the second very big issue is the distance. So that means if you're very close, you can disinfect very fast. If you're somewhere behind the door or the door is long distance, so that means the efficiency goes down and you need more time. The third point is the UVC power itself. So that means if you have, of course, more powerful lamps, you can have a more efficiency. And the fourth one is the time itself. So that means if you, for example, if you can use the UV light at nighttime, there is nobody in the room, then you can use the time that you say, okay, I do the treatment long time, so that I don't need to have so strong lamps. Yeah. So that means, finally, actually, it's not the power interesting; is the energy. We call it also UV dose. So in here you can see what I just mentioned before. Just that you compare the different energy, what you need for the different kind of microorganism. Yeah? For example, if you have E. coli, that's a very quite low UV dose what you need. So that means here about 9 watt second or millijoule per centimeter square. If you compare here with the fungal spores, this Aspergillus niger, you need about 40 times. So it's a quite big difference what you want to do. That's for us, I think, in a clinical or in a hospital environment, mostly you talk about bacteria, viruses. But for us, it's, for example, if we talk in the food industry, they have often mold problems. So that's for us always important to know where we want to or what kind of problems we have, that we have enough UV power inside this, let's say, application. That's just some examples. So we have a big list with other germs as well. So what is the safety issues? It's always like this, you know, if you have no power, nothing happens, right? So basically, if you have UVC light, you should not look inside the UVC light. So that means if you have an open UV treatment, you never can go inside the room. So that means you have to, either you have to switch it off, or you have, for example, to close it inside a, let's say, enclosure, pipe, or what else, that the UV is not going out to the persons. And that means also in practical use, if it's closed inside, you cannot treat the surface, only the air. But on the other side, for example, if you treat the room when nobody's inside, for example, then you can treat the surface and the air. Yeah. So, but there's also always, let's say, a safety we have to consider. Also, one thing is about the exposure time in general for, let's say, materials around. We had one client, for it was also a doctor. He put the UV light in the room, in a treatment room for night disinfection, yeah. And he thought it's very good to do a long time treatment every day, 8 hours or every night. And finally, after 3 months, he called and said all the plastics are yellow, yeah. And that's basically coming from the UV light. So that means that's also a thing we have to consider, that we don't make too much, yeah, just to prevent also the, let's say, the environment of the room, yeah. So, and just to have a summary, so the disinfection of the which for UVC you can go, let's say, I always say 99.99%, but you must be a little careful. If you go to the validation, they go to log 5. In practical use, for example, if you have air disinfection, you reach about log 1. Yeah, so that depends on the application itself. Also, the elimination of the microorganism, basically you can more or less eliminate all microorganisms. It's just a question of the UV dosage. That means mostly the time and the energy. Yeah, and also it's a very effective and fast disinfection. Before you saw some figures, we talk normally about seconds. Yeah, so it's a very fast method. It's a chemical free. That's sometimes necessary, sometimes not. And it's a very low cost, and basically also from the maintenance, the only thing what you do usually is changing the lamps, maybe cleaning of the lamps if there is a little dust coming or something like this, but there is no other maintenance necessary. So, and the other one, what I want to talk is the ozone. Before we saw on this scale if you use the 185 nanometer, we can create ozone out of the oxygen in the air. That means we make from O2, we make O3. Yeah, that's what we are doing. So that means we have O2 in the air. Then we use the UV 185 nanometer, and we generate O3. And O3 is a very good detergent, everybody knows, and is a very good effective, very good disinfectant in the air, especially, but also in the surface. So here we have similar features. What we have to think about. First, what ozone, actually this ozone disinfection, we have to think about the microorganism. That's also the same, let's say, criteria, as bigger, as more critical. Then we have the concentration. So that means if we have a low concentration, we will be less effective than a high concentration. Then also the time is an issue. And also what we have here is the environment. That means it depends, for example, if you have a room like here, everything is very clean, and you have no let's say, wallpapers or something like this, then you can reach a very high concentration. If you have, let's say, a floor inside a carpet or wallpapers, these wallpapers or carpets, they already react basically with the ozone, so that means you cannot reach this kind of high concentrations, like, for example, if you just have a room like here. That's also to consider. About the ozone. Ozone in general has a very bad reputation. Yeah, I think everybody heard, okay, very high ozone concentration in the cities, or the air is very bad, and blah blah blah. So that's on one side correct, but on the other side, if you go, for example, in the mountains, there you will have the highest ozone values, and nobody tell you the mountain is very unhealthy. Yeah, so the question is only in the cities you have a lot of dirt in the air, and ozone is a very good reference value to measure. So, and then that's the reason why they give it in let's say, ozone values. Yeah, but on here, that's a statistic from Austria. So you can see here in the mountains they have very high values. In Switzerland, I even heard they had some treatment villages only with very high ozone values to generate, I think, for the lung and for the blood. Yeah, so it's not that bad as its reputation. But also for the ozone, we have some safety issues we have to consider. There is we call it MAC value, and this one is in Germany. I think it's complete Europe also. It's 0.1 ppm for continuous exposure. That means 8 hours a day, or 0.2 ppm for exposure less than 1 hour. Yeah, that's in general. So if you check the values before in the mountains, we have much higher values, honestly. Yeah. So, but that's, let's say, in general from the Labor Law Association, that's somehow the limits we have to consider. Then this limit depends on the countries, but in Europe again we have this 0.1 and 0.2. Then we also have to think about the half-life time of the ozone. So that means if we do an ozone treatment, normally we need about 1.5 ppm to get a good proper disinfection. So that means we have a half time of about 40 minutes. So that means if we do this treatment, we cannot go directly inside the room without doing any action. Yeah. So in some applications, if there is no hurry, okay, we can do and just wait. Or if we need to have the room again, we have to do some, let's say, ozone destruction. And yeah, that's basically after the treated room, there should be a proper ventilation, or we do the ozone destruction. That's also a possibility. So now go to the practical side. So where we are using this kind of, let's say, these two technologies inside the hospital. We have first here, the first is the emergency room. That means where the people coming in, the first time coming with a emergency car. Then we have the patient room. Then another interesting area is the wet room. That means the bathroom of the patient room. Then we have, of course, the OT. Then we have, with one, bed processing. That's a project we made with a university hospital in Germany. Then, of course, we have normal waiting rooms, and we have treatment rooms, and also that's currently a little, let's say, fashion in Germany to take care about returned food. So that means disinfect returned food if it's not used. So then just go inside a little more. In the emergency room, yeah, everybody knows that's a very, let's say, fast coming and going. So that means if you want to use the rooms very fast, you have to do also a fast cleaning and fast disinfection. Yeah, and that's one method is to use what we have here, one of our UV towers, like this. That's open UV light, and we just treat it very fast. So normally for the small rooms, we just need about 5 to 10 minutes. We had one big hospital in our area in the southwest of Germany near Freiburg, and they could increase, for example, the efficiency in the emergency rooms by almost 30%. Yeah, so before they just clean it, but then they had to wait for the cleaning troop and so on and so on. And they changed to this kind of systems, and they can increase the efficiency about by 30%. So that means they are much more efficient. They don't have so long waiting times now in emergency areas than before. Then another issue is patient rooms. That's mostly related to this MRSA. That means usually if there is an MRSA patient, you have to do a very tough cleaning, proper cleaning. And the problem mostly is not the chemical. That's normally working very good. But the problem is mostly the application. So that means you can have a perfect chemical let's say disinfectant, but the problem is always basically the people who apply this one. Yeah. So you can do it very properly, you can do it half properly. Maybe it's Monday or it's Friday. So you have different people, etc. So and that's always a left risk inside this cleaning process. We did also there a field study, also in a big university hospital in the southwest Germany, where we checked 7 rooms. And after the treatment and after disinfection, we made to take the swab tests on critical surfaces, for example, like handles, like the bed handle, or the door, or the light switch, and something like this. And we found out of these 7, they still have problems. 3 of them still have problems with pathogens on this kind of surfaces after the disinfection. Yeah, so that's just a natural thing. Yeah, so and then we did put actually our device inside, run it like a normal operation, and then after that one, everything was fine. So that means we could reduce the risk of cross contamination by 100% with this kind of application. So another issue are sanitary rooms. So that means, I think here you will have the same problem like in Germany. Maybe you have 2 or 3 people, they are sharing one bathroom in a patient rooms. So that means this bathroom is always a risk of cross-contamination. Yeah? In Germany, normally it's cleaned maybe about 3 to 5 minutes every day. Yeah? So that means after each usage, it's already actually contaminated. And what we did about this one, we developed, let's say, automatic disinfection device. This one is a lamp. You can see here on the top, you have also a lamp function, not this one, there's LED. And the idea is this one, in this application, you run this after each usage. That means the patient enter the bathroom, switch on the light. If he's finished, he leaves the bathroom, switch off the light, and then after switch off the light, then we start to do a disinfection cycle. Yeah, and this disinfection cycle starts with the ozone lamp. That's the reason why we have 2 lamps inside. And this ozone, in this case, has not a disinfection function. Ozone has also the possibility to remove smell in the room. That means it destroys the smell particle. So we have always fresh air after the treatment. And then after this 3-minute ozone, we start the UV lamp for 30 minutes. And then basically with this UV lamp actually disinfects the surface and also the air in the room. Yeah. So that means after the treatment, we have a quite good disinfection. This was a test we made in our company actually on a very critical area. So that means, it's in German. So that means we take the test points, swab tests at the floor, at the wall beside the toilet, at the tap, at the light switch, and also at the door handle. Yeah. So in the first day, actually, that was the swab test made before we switch on the device. And then on the second day, we test again the same point. And the third day, we again was also the same. And then at the sixth day, that means after a weekend, we tested again the same points. So when you could see, even after the first day already, we are almost going down to 0. Yeah, that was without cleaning, just running the machine. Yeah. So that means we could control the surface and the air quite efficiently. Yeah, and this toilet maybe is used by 4 people. So that means they run it maybe 6, 7, maybe 8 to 10 times a day. So that means always through switching on, disinfecting, off, switching on, disinfecting. So we become maybe we start from 10,000, we go down to 5,000, from 5,000 we go down to 3,000, etc. Only through this kind of step down, we could reach this result. Yeah. Then we have applications in OT. In OT, we have the challenge, of course, between the operations, it's almost no time. Yeah, normally you have maybe 5 minutes time for cleaning, but there is no time for big disinfection action. So this application is more or less after the day, after operating day, you can really do a proper disinfection. Why to do that one? If you nowadays, OT rooms are very, let's say, technical. They have a lot of technical equipment inside. And if you really think about this, it's more or less not cleanable. Yeah, because there are so many corners and gaps or something. Even you have the perfect disinfection material, you cannot just not clean it. Yeah, we had actually the idea of this device, we call it UV mobile, was coming from a Fraunhofer Institute. That's a big research institute, and they have a, let's say, monkey research. And in this monkey research, they got TBC, and they basically all the monkeys almost start to dying. Yeah. So and they called us if you have a solution that they got rid of this TBC. And I went to that research institute, and they have this treatment, or basically this room, and it was full of equipment that actually they cannot clean it. It doesn't matter what they are using. And then that was the idea, not only to use UV. The idea was then to use UV in combination with ozone, because ozone is a gas which is going everywhere, even, let's say, below the equipment or behind, even inside the equipment. And so that means we have a much, much bigger treatment surface compared to only UV. And that's the reason, or actually the origin of this kind of UV mobile. So that you can see here, we start with a delay time. That's to go out of the room because we have open UV light. And then we start with the ozone for 25 minutes. And then we go with UVC. Why we do this kind of thing, or two-step operation? First of all, the ozone, of course, what we just learned, is a gas goes everywhere in the room, even the shadow areas. Because UV, you always, if you have here the UV light behind there, you cannot treat because it's a shadow, like a light. Yeah. But the ozone is a gas goes also here. So that means that's the reason why you're using ozone. Then we switch off the ozone and run UVC. And the reason why we do that one is, again, it's disinfectant, and also it reduces the ozone in the air, because we want to have an ozone level of smaller 0.1. That means we have to get rid of the ozone, and UVC actually destroys the ozone. And in addition, we have here ozone filter inside, which supports this process again. So that means after the treatment, the room can be used again on a safe way. So, and then bit processing. That was also, I just mentioned before, we had this project with a university in Ulm. And they had the problem how to process the beds. In practically, it's like this. They put it on the floor, and then some people clean it, blah, 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 with some detergents, and then they keep it on the floor. So it was not a very professional way. Some of the hospitals, they have these huge washing machines, but with the washing machine, you always have the problem. You have to bring the beds to the washing machine, and you have to bring them back. So it's a big logistical question. And so their idea was basically to use one of the patient rooms, and inside the patient rooms, or inside this patient room, they put one of these, I think 6 of these cleaner mats, what we saw before that was this device. They put 6 of these devices inside the room, and then they made the room full with the beds, pushed the start button. After 1 hour, the complete thing was disinfected. Yeah, so it was a very effective, let's say, and a simple method to get a better bed treatment than they had before. So, and then that's a typical Corona or COVID application. That means we see air disinfection because we learned in Corona there are not much possibilities to treat the air except with UV. You cannot push or spray the chemicals in the room or something like this. So, and that was or is still a very effective method, especially now in waiting rooms. So that means of doctors or also, of course, in the hospitals to disinfect the air from viruses. We are using different kind of air purifiers. So that means we can hang it on the wall, or we hang it on the ceiling, put it on cabinets. So different kind of applications. UVC disinfection of treatment rooms. That can be, for example, also dentists, where we have also the possibilities to use our UV mobile on one side, or we can use also the same what you did in the patient rooms, that we put this cleaner mat on the top of the chair, and we run automatic disinfection cycle after the treatment, maybe for 10 minutes or 20 minutes, and then the air or the area around of the dentist chair will be disinfected. So, and then that's what I mean before. That's a little fashion stuff in Germany because hospitals want to become green. Yeah, so they thought about what we can do, and they started with food waste. That they said, what can we do with basically food? For example, for breakfast, you have the jam or something like this, which is not used. Usually, it has to be thrown away until now. And they started now to think about, okay, can we disinfect it and bring it in the cycle back? So we save the jam, we don't need to buy again, and we do something, let's say, green, and we don't waste the food. And that's also, it's a simple but very effective method. So we use a kind of UV chamber. It looks like this, where you have a tablet, you put the stuff on it, put it in the chamber, and then it disinfects it, and you can use it again. It's a very simple thing, and I'm not so sure if the people here are thinking like this, or it's just let's say a fashion thing in Germany. But I think it's an effective method, and also it's approved in Germany by the authorities. So it's really working. And then we have also a solution that's also typical COVID experience in a lift, because in a lift you are very close, especially office buildings very close to each other, and there it's important to disinfect the air as much as possible, so that the risk of a cross-contamination or infection inside the lift can be controlled as much as possible. So I think, that's some additional applications, but it's not just for your information, where UV light is used as well. That's for wound healing. That's a new. It's still under research. That you use, for example, UV light. In this case, they are LED to disinfect fresh operated wounds. That's also, I think, it's very in future very good application. Then we have a UV treatment in the printing sector. It's also very common. Then also even artificial aging of wood. for music instruments, they are also using UV. So you can see UV is a very, very broad or very wide use technology. Yeah, that's all